Hi. Today I'm going to do a video on how to build a custom MicroPython firmware for the ESP8266 on your Windows machine. And what this requires is a VirtualBox image of Ubuntu, and that is used to actually build and compile the firmware. So to begin with, two things you'll need is VirtualBox from Oracle, and I've downloaded and installed that. And the second thing you'll need is the Ubuntu 16.04.2 desktop ISO image. That's what we'll use for the virtual machine. So let me go ahead and get started. I'll start up VirtualBox, and let's see. First thing I'll do is create a new virtual machine, and let me go ahead and name that to be ESP Builder. And I want that to be a Linux virtual machine, Ubuntu 64-bit. I'll click next. I'll give it let's give it 4 gigabytes of RAM. I'll create the virtual hard disk now. I'll use a VDI image, and I'll dynamically allocate it. Let's make it about 20 gig, just to make sure we have enough room. And once that's created, I'll select it and click on storage. And what I need to do is click on this optical drive icon and change it to point to the Ubuntu ISO image. Once I can do that, I click OK, and now I'm ready to boot the new virtual machine. So let me do that. It will start up, and let's see, it'll take a few minutes. You could probably use a later version, but the documentation recommends using 1604. So since it's easy enough to get a copy of that, that's what I downloaded and practiced with. So all these instructions are based on that version. Okay, now it's booted up with the Ubuntu ISO, and the only thing I need to do is install it. So I'm going to go ahead and click on install. And let me download the updates and install third-party software. And I'll leave the option at erase disk and install Ubuntu, and click on install now, and then click on continue. It'll ask me for my location. I'll click continue. It's the right time zone for me. Keyboard layout, US English is right for me. And let me give it my user information for the one user. I'll give it a simple password for now. And since it's a virtual machine, I'll just go ahead and log in automatically. Okay, and now to begin to install, or continue installing. This should take about 10 minutes. I won't go through the install. You'll see that as you do that. But what I will do is pause the video and start back up once this is finished and ready to continue. Okay. Okay. Now that the installation is completed, I'll go ahead and click on Restart Now. And hit Enter. Let it reboot. And now I should boot to the desktop. Okay, there we go. Let me go ahead and make this bigger. Yeah, no problem there, but it works. Okay. Now that we've got a fresh Ubuntu install, there are a couple things we need to do to get it ready. Let me take a look at my notes here. First thing we'll want to do is install the guest editions, and then to do that, what that does is allow the virtual box or the virtual machine to realize that it is running in a virtual machine, and it helps make things work better. So I'm going to select under Devices, Insert Guest Edition CD Image, and it'll ask me if I want to run what's on there. Say Run. It'll ask me to authenticate. And it should be pretty quick. And while this is running, it's a good idea to go ahead and right mouse click the terminal icon and select Lock to Launcher. We'll be using a terminal later on, so it's useful to do that. And still installing. Okay. And now it's finished, so I'll hit return to close the window. But the other thing you want to set under devices is the shared clipboard. We'll go ahead and set that to bidirectional. And then what we want to do, in order to get files on and off our virtual machine, we'll set up a shared folder. I'm going to go ahead and add one to my D drive. Just to make it convenient, make it auto mount, make it permanent. Click OK. Okay. Now I'll go ahead and eject the Vbox editions. And now the only thing I probably need to do is we'll go ahead and restart it just to get all the settings straight. And okay. And the last thing I want to do is check to see if I have access to my shared drive, which I don't. And that means I need to add my user to the group that has access. And the way to do that is I open up the terminal. And let's go ahead, while we're in the terminal, let's go ahead and make it a little bit bigger and easier to see. That didn't seem to work. Edit profile preferences. Oh, custom font. There we go. Okay. Now the way to add ourselves to the correct group, we're going to say sudo user mod -a -capital G. The group we want to add to is the box shared folder, and the user is our user. This is for password. Okay. Now what we'll need to do is log on and log back off. So let's do that. Log out. Log back in. And this time we should have access to our drive, which we do. Okay. Great. Now we're all set to begin with the actual stuff that's specific to MicroPython. Right now, you might want to save a copy of this virtual machine, so in case you make a mistake, you can restart. But it's easy enough to recreate, so that's fine too. Let's go ahead and pause here, and what I'll do is come back and show you the process of creating a MicroPython firmware. Okay. Okay. Now let's go ahead and start the process of taking our new VirtualBox Ubuntu image and making it so that it can build a MicroPython image. I'll go ahead and refer to my notes here. And first thing I wanted to make a note of is the very first step is installing the ESP-Open-SDK. And this is specific to ESP8266 chips. You don't have to do this if you're compiling MicroPython for another board. But since we're doing the ESP8266, it's required for us. And what I'll do is post a link to the Github website where all these instructions are coming from, both for this and the MicroPython. And therefore, that way you can follow along with what I'm doing. Now, what I did here is I brought up the ESP-Open-SDK on GitHub, and in the instructions for Ubuntu, I'll need to install some prerequisites. So let me go ahead and start up a terminal window. Okay. And let's cut and paste the first set of dependent prerequisites. And I'll paste that in. and hit enter. It asks me for a password, and go ahead and install that. This isn't too long. It's a moderate number of packages. But I found that you will have to install second line in the instructions, and I'll do that in just a second. And it should be finishing up right here. There we go. It's a sudo apt-get install libtool-bin. That is required, so I'll copy and install that. Okay, now we've got all the prerequisites installed for the ESP-SDK. Now what we need to do is actually get a copy of it from GitHub onto our local machine. And I'll do that with the command also in the instructions, git clone. And I'll run that. Now I'm running this from my home directory, so what it'll do is create a subdirectory under the home directory, which is fine. We don't have to spend too much time organizing ourselves. This is just a machine to build the MicroPython firmware. Okay, so that's been run. Now all we need to do is run make, and just do that by doing this. Oh, sorry. You have to change directory into the ESP-Open-SDK, then type make. Okay. Now this in itself will take 10 to 15 minutes itself, so what I'll do is go ahead, again, pause the video, and start it back up once this is finished compiling. Okay, that took a little bit longer than I thought, maybe 20 to 30 minutes, but it all depends on how much resources and kind of machine you have. But the end result you want to get when you're finished is this export command that it leaves you with at the very end. I'm going to go ahead and select it now and execute it. Copy that, paste, and execute it. And that actually puts the end result of all that build for the ESP-Open-SDK was to be able to export that command and put the executables for the SDK on your path. Okay, so that is should be the end of the yes. Once you've exported that, now we're ready to begin working on the MicroPython itself. Okay. Now I found, based on the instructions, that you'll need to install one other thing. I found it was missing in the subsequent steps, so I'm going to go ahead and do that now. Let me go back up to the home directory, and it's sudo apt-get install libffi-dev. That was one library that was missing, and I'll go ahead and install that. It's a very small library, so it shouldn't take very long. Okay. Now I'm ready to begin the actual steps for working with MicroPython. Okay. First thing I want to do is clone the repository from GitHub. So that's simple enough. In my home directory, I'm going to do a git clone https github.com micropython/micropython.git and execute that. And it's not a very big project, so it should only take a minute. Okay, and it's done. Go into that directory. It should be MicroPython. Okay. And what we need to do is first get all the submodules with the command git submodule update --init. And that'll get some of the sub-projects that it requires. And that's done. And the next step is we need to build a utility that we'll use to compile MicroPython source files. Let me paste it in here. And it's called mpy-cross. So let me go ahead and that's used by the build program to precompile MicroPython source to go onto our image. And yeah, that's pretty quick. And once that's done, okay. Now, what we'll need to do, and based on the instructions, is we need to compile the Unix version of MicroPython because it's used to install other modules into the ESP8266 port of MicroPython. So let's go ahead and just do those steps right now. I will go ahead and go down into the ports. Should be a Unix port. There is. And once I'm there, I'll need to issue two make commands. One is make axtls, and then finally make. And these are all pretty quick, so we shouldn't have to pause or break in any more steps. This should finish up in just a minute. There we go. The way you can test this is you can just run MicroPython. And there we go. Control D will show you the out of the MicroPython REPL prompt. Once we know that that's up and running, what we'll want to do is go ahead and put MicroPython on our path. So based on where you installed it, but if you installed it as I have here, all you have to do is export the path and put this new path for Unix in the path to make MicroPython accessible from any directory. And that's what I'm going to do here. And the way to test that is I'm going to go down one directory, then up the ESP8266 directory, and I should be able to run MicroPython from here. And I can. So that's what that was to accomplish. Okay. Now that we have MicroPython on our path, we can use MicroPython pip, upip, to install modules into our ESP8266 module, or firmware, or that we want, custom firmware that we want to build. But right now, what I'd like to do is go ahead and build the firmware because we're ready. I've already gotten into the ESP8266 port directory, and if you can see here, it will come with a modules subdirectory. So I'm going to go into the modules subdirectory and take a look in there. Basically, to freeze a module means simply placing it in this directory before you do the build. It's as simple as that. Some of the modules that you want to install will come from the MicroPython library, and you can use the upip command to do that, and that makes it easy to install and more standardized. So whatever you can, use upip. Otherwise, you can just copy your .py file directly into the module subdirectory. Okay. To give you an example of that, well, before I do that, let me go ahead and just show you how easy it is to compile a MicroPython firmware bin file. I'm going to go back up one directory. So now that I'm in the ESP8266 directory, it's basically these things. Since I haven't made anything before, I don't need to do a make clean, but I do need to do a make axtls before I begin. Okay, once that's completed, then all I simply need to do is do a make. That will create a subdirectory called build, and in that build directory will be our final bin file, and we'll see that in just a minute. Okay, and there it said we created the firmware-combine.bin. I wanted to look at the file. Firmware-combine.bin, it's about 578 kilobytes. And everything looks fine. Last thing you'll probably want to do is, you can open up the file manager for this, makes it easy, is take your firmware, go to MicroPython, ports, ESP8266, build, take firmware-combine.bin, copy that, then go to your shared drive, find a location there, and paste it there. And that's all you need to do to compile your own. But let me go ahead and show you how you want to customize that before building one. Okay, and that'll show you how to rebuild. Because you may want different firmware for different reasons with different frozen modules. Therefore, it's good to keep the virtual machine around. Therefore, it's good to keep track of what you put in the modules directory. What I'm going to do is install. You do it two ways. Okay. First way is I'm going to use MicroPython to install a standard library module. And to do that, I'll run the command MicroPython-m upip install -p modules, and then the module I want to install, in this case MicroPython-ua sync.io. If you do that, it'll basically download it and put it in the modules directory, and I'll show you that here. See, it downloaded and created a subdirectory. That's what it means. It's a little bit more standardized to do it this way. The older alternative is simply to copy something in. Let me go ahead and finish using upip to install the other packages I want to install. Package resources, and let's see, logging, MicroPython logging. These are just things that I like to put on my firmware. And then finally, let's go and copy. Let's see. There we go. Let's go ahead and copy some modules into module subdirectory to be frozen. I'm copying them from my shared drive. Okay, once those are copied, that's all I need to do. And this is how you rebuild once you've built. What you need to do is from the ESP8266 directory, issue a make clean, then make axtls again, and finally a make. Now, it is possible for you to put too much code, it frees too much code, and it will make the bin file too big. I'm not sure exactly what that size limit is, but just be aware that this can fail, and you may have to remove some items in that case. This one worked fine. Looks like it's ready to go. And I think that's really all there is to it. Hopefully this will help people utilize MicroPython in different and better ways. And if you have any questions, go ahead and post them in the comments below, and I'll see what I can do to help. Alright? I don't think there's anything to do other than copy the firmware to my shared drive. What I usually tend to do is, once I've got the firmware copied to my shared drive, which I'll do now, let me go ahead and do that now. Go to the build just one more time. Find the firmware, combine them in. Let's go ahead and copy that. Then go to the shared drive and just paste it. Cancel that. Delete the other one first. Then just paste it. There we go. Okay. Once you do that, what I generally tend to do is just close VirtualBox and save the machine state. That way, next time you need to build, you can just start up exactly where you were. And that's what I'm going to do right now. And it's pretty quick. And I want to kind of end up where we started. And there we go. Go ahead and shut down VirtualBox. And that's about it. Here we should have on my D drive a firmware.combined.bin, which we can use to flash a MicroPython device, or ESP8266 MicroPython device. Okay, I think that's it. I'm going to leave it there, and hopefully this will help someone have fun with this. Bye.